Continuing on with our primary pollutants, we're going to look at the carbon oxides, COX, or carbon monoxide with one oxygen, or carbon dioxide with two oxygens, and the difference is in the combustion. So carbon monoxide is formed during incomplete combustion, where carbon dioxide is formed during complete combustion. And so carbon monoxide and carbon dioxide are formed when we are combusting fossil fuels and other kinds of biomass, such as wood. But remember, the oxygen comes in from when we burn things. So combustion needs oxygen, and so that's what gives us our oxides. And so carbon monoxide comes from vehicle emissions mostly, but also from industry. Like I said, when you're burning fossil fuels, we do get carbon monoxide emissions. And carbon monoxide is a very common indoor air pollutant, which is why we should have carbon monoxide detectors around our home. So in underdeveloped countries, you have wood burning stoves that are poorly ventilated and for cooking, and you end up with a lot of carbon monoxide levels. Where also you have fossil fuels that you're burning. So if you have oil in your home, the combustion of that in your boiler can also lead to some carbon monoxide. So if it's not properly ventilated, it can be dangerous. Again, why you should have these carbon monoxide detectors throughout your home. And the reason why it's so dangerous is because it reacts with hemoglobin in your red blood cells. So hemoglobin transports oxygen, and so if the carbon monoxide is around, your carbon monoxide will actually bond with your hemoglobin more readily than oxygen. And so your hemoglobin won't be available to carry oxygen because it already has carbon monoxide on it. And so this can cause a whole range of issues depending on how much you're being exposed to. But heart attack, lung disease, nausea, headache, and ultimately death, right? They call it the silent killer because it's odorless, tasteless, and that's, again, why you should have those detectors in your home. Whereas carbon dioxide is formed during complete combustion, like I said, and it is a greenhouse gas. But the problem is that it's not regulated as strictly as other air pollutants. So it's not a criteria air pollutant. It's not regulated through the Clean Air Act. And as you can see by this graph that you've seen before in the past, and you will see again, our carbon dioxide levels are steadily rising. And again, there's this constant up and down. There's an annual cycle. And so you can see that our carbon dioxide levels are the highest going through the winter into spring. And the reason for that is because photosynthesis is not happening as much because the leaves are not on the trees and in the northern hemisphere. So remember, the most land is in the northern hemisphere, and so that's why these levels are dictated by the seasons of the northern hemisphere. And again, while in the fall, you see levels that are the lowest because we've gone through a summer of lots of photosynthesis with leaves on the trees. And so in the fall, it again carbon dioxide starts rising again because the leaves are starting to fall off the tree, photosynthesis rates go down. And so here again is kind of a fuzzy graph of what I just said. So volatile organic compounds, or VOCs, from here on out are organic compounds that evaporate, pretty readily at typical atmospheric temperatures. So they evap very, very easily. So for example, right, these are all paint cans, and you can see, right, you have low emissions, high VOCs, and some of them have no VOCs. And so obviously if you're painting in your house and you don't want to breathe them in, you're going to be around that area before they can off gas. You want a low VOC paint. but they come from other things too. So they do come naturally from a few plants. It's not a large source, but it does happen. Dry cleaning fluids, solvents, gasoline, anything you kind of take a sniff and has a pretty, you know, telling odor, I guess you could say. Most are carcinogenic, so they cause cancer. They can cause liver and kidney damage. So VOCs are definitely not good for you by themselves, but in combination with other things, they can lead to photochemical smog, which again we will talk about at length. And finally, we have ozone, and ozone is not a primary pollutant, it's a secondary pollutant because ozone is not emitted directly into the atmosphere by any source. Instead, it's a reaction. And so, ozone is the major component of photochemical smog. It reacts with NOx and VOCs to give us ozone. To give us photochemical smog. And again, we will talk at length about this, so more to come on that. But on its own, it can actually cause lung irritation, damage, bronchial constriction, coughing, wheezing, eye irritation, because it actually affects tissues. So your body tissues, plant tissue. So it actually can cause some damage on its own beyond the photochemical smog aspect of it. And it can damage other goods such as fabric, rubber, plastics. So really, it's just breaking things down. And here's a little photo, um, a little infographic, sorry, about ozone and about where it comes from. And so this will be helpful when we talk about photochemical smog. And then where it is in the atmosphere and such. So remember, here we're talking about tropospheric ozone, right, the bad ozone, as opposed to stratospheric ozone, which is the good ozone, which we will hit on more in the future.